Hello everyone, hope you're all doing well, having a great time, staying at home, and of course staying safe. So this is a class 9 science lesson, and in this lesson we will try to talk about energy from the nucleus. Of course we are still in chapter 14, atomic energy, and section 2 as you can see, part 1. Since we want to talk about how we can get energy from the nucleus, you should know that getting energy from the nucleus of the atom has benefits and, of course, hazardous. So in this section, we will try to talk about how we can get energy from the nucleus, fission and fusion. It is very important for you to know what is the advantage and disadvantage of fission and fusion. طبعا لم سكشنها بس يشيكين بس يوكين شو نتوان وزمان دس كويلا ناوكي قديلي يعني قديلة وسودو زيانة كاني تشين وهروها دورقا فيربين درباي دس كوتني وزل ناوك أو دورقاش ناويان شيا يكمان ناوي nuclear fission دوميان ناوي nuclear fusion يم بندباسي أو دورقاكا. So what is nuclear fission? To answer that question, you need to learn that the nuclei of some atoms decay by breaking into smaller pieces, more stable nuclei. Okay, nucleus هنا أتومكان لتشان ليت شيبونها بسريت أبن دبي شيبونوي بسرية ودبي بدو ناوكي بچوك وجيجيرتر يعني stable تر. So now we can answer that question. What is nuclear fission? Is the process by which a large nucleus splits into small nuclei, and in this process it releases energy as a result of conversion of the part of the mass of the original nucleus. So what is going on? What is happening? We have a large nucleus that actually splits into two smaller nuclei. And of course, it releases a lot of energy in this process. That's not it. A part of the mass of the original nucleus changes. كاوتا تشيرويا ناوكي جورا مانهبو ناوكا سبلت بو بدو ناوكي بشكتر ولأن طبعا انرجيكي زوري دربران وبشيكيش لشي بشيكيش لماسكي. The mass of the original nucleus will change. An example for this process is uranium atom. The nuclei of some uranium atoms as well as nuclei of other large atoms can undergo nuclear fission naturally. Now if you look at the picture in front of you, you will see large atoms of uranium is forced to undergo fission. How? By bombarding it with the neutron. So you have a neutron with no charge and a uranium 235. Then what happens is actually change into barium 142 and krypton 91. So جاري كتير أتواني أتوم جورا كان والبكي ببروسي فشنا بروا چون با بردمان كردنيان با نيوترون وكل بيع لنموني يورانيوم كهايبيني. Now moving on to the energy from the matter. Now, do you know that matter can be changed into energy? Yes, matter could be changed to energy. Look at the picture in front of you and watch the total mass of a product and compare it with the total mass of a reactant. You will see that the total mass of the product is slightly less than the total mass of a reactant. Now, this is the important question. Why are the masses different? Now you know that the product was not only krypton and barium. There was actually energy in the middle. So some of the matter was converted into energy. وتمان اگر براود بکەی لە بینی ماسی کار لە کردو لەگەڵ بەرهەمهاتوو ئەبینی جیاوازی هەیە لە بینیانە. ئەو جیاوازی ئەگەڕێتەوە بۆچی؟ ئەگەڕێتەوە بۆ ئەوەی هەندێک لە مادەکە گۆڕاوە بۆ وزە. We will have to say another thing. The amount of energy that given with a single uranium nucleus split is very small. But this energy comes from a very small amount of matter. The amount of matter converted into energy is about 1/5 of the mass of hydrogen atom. And you already know that hydrogen is the smallest atom that exists. Let's talk about nuclear chain reaction. To understand nuclear chain reaction, you will have to understand what is the nuclear fission. Nuclear fission was the split of a nucleus of a large atom into two or more fragments. Release additional neutrons and energy. Now I want you to remember the example of a uranium 235. In this example, we had a uranium 235 atom, right? And we bombarded with neutron, as you can see in the picture. Okay, so the end result was barium, krypton, and 3 neutron. These 3 neutron, imagine, suppose that each one of these 3 neutrons split other uranium 235 nuclei. Energy and more neutrons are given off. Now let's say that 2 or 3 of those neutrons were given off split other nuclei, and this process didn't stop. So this is example of nuclear chain reaction. Nuclear chain reaction is a continuous series of nuclear fission reaction. So, a continuous series of nuclear fission reaction is called nuclear chain reaction. So remember, it started with a neutron. This neutron split the nucleus of the uranium, and in the end result we will have barium and krypton and 3 neutrons. And these neutrons also has the capability to go and split other uranium atoms. And a continuous series of a nuclear fission is a nuclear chain reaction. So وتمان imagine 2 یان 3 لەو نیوترۆنانە هەڵە سێبەلەتکردنی یۆرانیۆمیتر و لەو کاتەیە وزە دەرەپەڕە و نیوترۆنی تریش دەرەپەڕە. ئۆکێ ئەم نیوترۆنانەی تر هەڵەسن بە لەتکردنی ناوکی یۆرانیۆمیتر و لە هەمان ریاکشنە نیوترۆنی ترمان دەسەکەوێت لەگەڵ ئێنەرژی ترە. ئەن ئەم ریاکشنە بەردەوام بێ بەم شتە ئەوترێ nuclear chain reaction. So the first picture here is the picture of a nuclear reactor. A nuclear reactor or a nuclear power plant have these parts and work in this way. Uranium 235 nuclei in the fuel rods. In the picture in front of you, you will see the fuel rods. It has a black color in this picture, but in your book it is blue. Undergoes a nuclear chain reaction, and we have control rods. In your book it is gray, but in this picture it is purplish color. Let's go with purple. And actually this control rods absorb neutrons to keep the chain reaction at safe level. Then we have the energy that the energy from the chain reaction is absorbed by a coolant, and usually the coolant is water. The water absorbs energy from the hot coolant and change it to steam. The steam turns the turbine attached to the generators. The generators change the mechanical energy of the spinning turbine into electrical energy. And that's how the nuclear reactor or nuclear power plants work. Now let's answer the question. The question says, what is the result of uncontrolled chain reaction? It is important for you to know that in uncontrolled chain reaction, huge amount of energy are given off very quickly. For example, the tremendous amount of energy from atomic bomb is the result of uncontrolled chain reaction, as you can see in the picture in front of you. Also in the power plants, they use controlled chain reaction. Let's answer the second question. What is the use of controlled chain reaction? Controlled chain reaction is used to generate electrical energy. The energy released from a nuclei in uranium fuel in the nuclear power plant is used to generate electrical energy. You know, every form of energy has advantage and disadvantage. To make informed decision about energy use, you need to know both the advantage and disadvantage. For example, burning a wood could keep you warm, right? In the cold night, in a forest. It also could make the whole forest on fire. What most peoples and countries are worried about is using nuclear energy in wars and against human lives, as it has been used by US against Japan in 1945. As you can see in the picture in front of you, that is the picture of Hiroshima and Nagasaki. The Americans dropped atomic bombs on these two cities, and this led to death and injury of hundreds of thousands of Japanese and the destruction of widespread ecosystem there. And also, nuclear accidents all actually pose a great hazard to human life. Like I said in the previous lesson, the explosion at Chernobyl nuclear power plant in Ukraine in 1986, which led to release a large amount of radioactive uranium fuel and nuclear waste product into the atmosphere, and that spread over most Europe, Asia, and North America. أول خلقك بكاتو يعني خلق دودلك درباري nuclear energy أويك أشي هري بولاتك لو بولاتاني كنيوكلير energy هي بكاري بين بو شاركدن برانبر ولاتي كتير. For example, USA لسال 1945 دو بومبي أتومي تقان لا جابان بو هوي أوي هزاران صدان هزار کس بکوژه نک هزاران صدان هزار کس بکوژه و لناویان بره ایکوسیستمی کی زور لناو بره یعنی هنه جاربه اکسیدنت روه و کوی چرنوبل لچرنوبل اکسیدنت لناو نیوکلیر پاور پلانت که رویا و بو هوی تقانوی چرنوبل همو پاور پلانت که by the way چرنوبل حتی استش کسی تیاناجی يعني افکتکی حتی استش ما لهشتاوششا حتی استا شوێنێک نییە ژیانی تا بکرێت. خەڵک وەکو میوزیەم ئەچە سێریەکە، یعنی خەڵکە چێتە ژوورەوە بۆ ماوەیەکی کەم تیا بێت سێری شوێنەکانەکە و یەتە دەرەوە. ڕسمەکان ئەو پیشانە ساتی تەقینەوەی بۆمبەکان لە جاپان لەگەڵ چەرنۆبڵ. Moving on to the nuclear waste. One of the most important and urgent issues related to nuclear energy is the nuclear waste. Among these wastes are, for example, the fuel rod, the chemicals that is used to use uranium, or the shoe covering that is used by the worker that actually work in the nuclear power plant, or the overall that actually the workers use. Now the control fission has been carried out for only about 50 years, but the waste will give off high levels of radiation for thousands of years. You also know that the rate of radioactive decay cannot be changed, so the nuclear waste must be stored until it becomes less radioactive. Now the picture in front of you actually shows you how they store it. Nuclear waste must be stored until it becomes less radioactive. As we said, most of the used fuel rods are stored in huge pools of water. What about the liquid waste? The liquid waste are stored in underground tanks. Nuclear waste یەکێکە لەو مشکلانەی کە is related to nuclear energy. So پاژماوەکان چین؟ پاژماوەکان for example fuel rod یان ئەو کیمیکەڵانی کە لە ئامادەکردنی یۆرانیۆمە بەکارێنرێن، یان ئەو جلانی کە کرێکارەکان لەبەریەکەن، یان ئەو کەڤەرانی کە بۆ قۆنەرەکانیان بەکارێنن، ئەمانە هەمووی بە پاژماوەی ناوەکی بەکار دائەنرێت. تەنها 50 ساڵە nuclear fission پرۆسی nuclear fission نەکرێ، بەڵام پاژماوەکانی بۆ هەزاران ساڵ radiationiانە بێ. So چۆن پرۆسسینی ئەم پاژماوە ناکەن؟ for example ئەوانی کە لیکویدن لە تانکی گەورەیە هەڵەگیرێ لە ژێر زەویە، یان فیول ڕۆدەکان ئاوێکی بۆ نمونە پۆڵێکی گەورە لە ئاودانن و فیول ڕۆدەکانی تێەکەن و زانەکانیش بەردەوام بیرەکەنەوە توێژینەوەکەن بۆ ئەوەی ڕێگەی تازە بدۆزنەوە بۆ لە ناوبردنیان هەڵگرتنی پاژماوە ناوەکیەکان. We actually reached the end of this lesson. You can actually try to answer the questions in section review in 271, page 271, if you could. And at the end, thank you for your attention and thank you for your time, and good luck and have a great time.